Welcome to confidence intervals. All right, the ideas we're going to talk about in this video: confidence intervals and their interpretations, proportions intervals, the t-distributions, means intervals, and minimum sample size. So confidence intervals. There's a formula to it. It's the statistic plus or minus the critical value times the standard deviation of statistic. What a confidence interval is, though, it's an interval of plausible values for a parameter. So if I say that I have a confidence interval that goes from 0.73 to 0.86 for p, then those are all the values that I find plausible for the parameter p. So I do want to examine this formula though. The statistic is either x bar or p hat. The critical value is either a t star or a z star. And then the standard deviation, those formulas are given on the AP stats sheet. For means, it's sigma over root n, and for proportions, it's square root of p 1 minus p over n. Now, in confidence intervals, we're going to be using p hat in this formula here, but in general, it's p. The margin of error is this part. Everything after the plus minus is what we call margin of error. So you've probably seen that before in like presidential polls, right? Like it's 48% plus or minus 3%. So then that would be a confidence interval of 0.45 to 0.51. All right, interpreting the confidence interval is something like, so I capitalize this for a reason. The confidence interval is interpreted something like we're 95% confident the true value of whatever is between blank and blank. Interpreting the confidence level, so this is saying what does 95% confident mean? It means if we repeated these methods many times, the confidence interval would capture the true value of blah, whatever the parameter is, in context, 95% of the time. So those are interpretations. Okay, every inference thing ever, state what you're doing. For confidence intervals, we're trying to estimate parameters. Plan your inference procedure, including naming the type of interval and checking conditions. Do your calculations. The calculator does it all for you. You're just going to report the interval and make a conclusion in context about the meaning of your confidence interval. Conditions? What conditions? For proportions, randomness, normality, and 10% condition. The randomness, it's usually stated, 10% we're pretty familiar with, but population size must be at least 10 times the sample size. Normality with proportions is done with large counts. So that's np hat's greater than or equal to 10 and n1 minus p hat is greater than or equal to 10. All right, so proportions are always going to be a z interval. I should mention that as well. Z interval. So we'd say like 1 proportion z interval. With the means, however, there's a lot of information missing, right? Like we don't know the population standard deviation. So there's no way that we should really be using a normal distribution. So we don't. We use the t-distribution. With means, we use the t-distribution because we don't know the population standard deviation. The t-distribution varies depending on how many degrees of freedom you have. So there's like a bunch of different types of t-distributions, but the way we get the one that we're going to use is with the degrees of freedom n minus 1. So that's sample size minus 1. At least when we do one sample stuff. It gets more complicated with two sample stuff, but your calculator will spit it out at that point. The t-distribution looks a lot like the normal distribution, but it has a lower peak and fat tails. As the degrees of freedom increase, though, the t-distribution does approach the normal. So if you had somehow managed to get an infinite number of degrees of freedom, that is a normal distribution. So that said, we got to check conditions for means as well. We have our randomness, we have 10%, those are normal. The normality, we still do need normality, which I know seems weird, but we need normality in order to do a confidence interval still. It's weird because we use t-distribution, so why does it need to be normal? But just go with me for a second. Any of those three conditions will satisfy the normality. Either the population is normally distributed, the sample size is at least 30, or a graph of the data doesn't look horrible. Really hope we don't have to do that graph. All right, last thing we're thinking about is the minimum sample size. So sometimes they tell you like, oh, we want this margin of error and this confidence level. So what sample size do we need? Sunny? I don't know why they're from the 20s, but they are. You should always have enough information to algebra this out. Remember, the number for the sample size that you get always has to be rounded up. Usually they will give you some pilot information. But if they don't for some reason, if specifically with proportions, then just use 0.5 for p hat. To get the z star for the margin of error, because remember, margin of error is going to look like this. The z star comes from inverse norm. This is from the formulas that are on your formula sheet. Based on a survey of a random sample of 900 adults in the United States, a journalist reports that 60% of adults in the United States are in favor of increasing the minimum hourly wage. If the reported percent has a margin of error of 2.7 percentage points, which of the following is closest to the level of confidence? All right, so this right here, that's p hat. This is our margin of error. So error is equal to, for proportions, it's going to be some critical z star. And then we're going to need the standard deviation. So that's going to be 0.60 for us times 0.40 over 900. Right? So that is the formula. We don't know the z star. However, we can figure it out. So the error was 0.027. Okay, now if I find out what this number is, should be able to just divide. So let me get out my handy dandy TI Inspire CAS. Texas Instruments, you should sponsor me. 0.6 times 0.4 divided by 900, and then I take the square root of her. So that's 0.027 equals 0.01633 times z star. I put it in the other spot, but that's fine. Then if I do the division, so I'm doing algebra from here, 1633. So then the z star is 1.65. Okay, now you might be wondering, like, well, how did that help us? Well, the normal distribution should look like this, and we're basically here at 1.65. A confidence interval has space in both tails. I just need to figure out how much space is actually, I don't want that space. This is going to be a really big eraser, and it's bigger than I want. I need to figure out how much space is in here. So the confidence interval should be symmetric, so it should be negative 1.65 to positive 1.65. So I should actually be able to use normal CDF to figure out what that space is, and that's my confidence level. So I'm going to go into distributions, normal CDF, negative 1.65 to positive 1.65. Since I'm using a z-score, the mean and standard deviation are 0 and 1, and I get 90% confidence. I'll write out my normal CDF calculation. Okay, so this was a kind of weird one to get started on, but oh well. A large sample 98% confidence interval for the proportion of hotel reservations that are canceled on the intended arrival day is 0.048 to 0.112. What is the point estimate for the proportion of hotel reservations that are canceled on the intended arrival day from which this interval is constructed? All right, so the point estimate, the sample statistic, is always dead center of the confidence interval. So in order to get that, I just average those. So 0.112 plus 0.048 divided by 2. 0.08. That's it. Just stats things. A random sample of 50 students at a large high school resulted in a 95% confidence interval for the mean number of hours of sleep per day, 6.73 to 7.67. Which of the following statements best summarizes the meaning of this confidence interval? I want to point out before I do this problem, I don't like the way it's worded. I think that this should say confidence level. However, we will proceed. The first one says about 95% of all random samples of 50 students from this population would result in a 95% confidence interval of 6.73 to 7.67. There's no reason to believe that. Not every confidence interval is going to be the same, let alone 95% of them. About 95% of all random samples of 50 students from this population would result in a 95% confidence interval that covered the population mean number of hours of sleep per day. That's an interpretation of confidence level, but it's not wrong. So I'm going to leave it for a second and see if anything else sounds better. 95% of the students in the survey reported sleeping between 6.73 and 7.67 hours per day. That's not necessarily true at all. That's a misuse of the 95%. The 95% doesn't have anything to do with the sample. 95% of students in this high school sleep between 6.73 and 7.67. That's getting more on the right track, kind of, but still not really, because at least it's talking about the population, but that's still not a true interpretation. A student selected at random from this population sleeps between 6.73 and 7.67 hours per day for 95% of the time. That doesn't even make any sense. They sampled one day, right? Like they asked like what people do in general. So it's not like 95% of the time you're in that interval. So none of these answers really are a good meaning of a confidence interval, but A, C, and D, and E are outright wrong. So we're going to have to go with the one that interprets confidence level. Oh well, just stats things. A random sample of 432 voters revealed that 100 are in favor of a certain bond issue. A 95% confidence interval for the proportion of the population of voters who are in favor of the bond issue is ... Well, I'm trying to get a proportion, and A, B, and C are talking about values, so they're not right. That's talking about the 100 that there actually were. So it's either D or E. And the only difference between D and E is this right here. 1.96 versus 1.645. That's our z-score, right? So I'm supposed to be doing a 95% confidence interval. To get the z-score, I'm going to do inverse norm. So 95% is in here, right? So that means 5% is left for the tails, which means that this area right here is 0.025. That's the area I'm going to put into inverse norm. I'm looking for a z-score, so mean is 0, and the standard deviation is 1. I do that, I should get 1.96. So the answer is D. In 2009, a survey of internet usage found that 79% of adults aged 18 years and older in the United States use the internet. A broadband company believes that the percent is greater now than it was in 2009 and will conduct a survey. The company plans to construct a 98% confidence interval to estimate the current percent and wants the margin of error to be no more than 2.5 percentage points. Assuming that at least 79% of adults use the internet, which of the following should be used to find the sample size n? Okay, so we're supposed to assume that p is 0.79. So that means A, B, and C are going to be wrong because those all use 0.5. So remember I said if they don't give you anything, use 0.5 for that. But they gave us 0.79. So now it's just a matter of should it be 0.025 or should it be 0.05? Well, basically what we're doing is we want the error to be less than or equal to z star p1 minus p over n. Because right, that's the error formula that I just wrote. So I want the error to be greater than or equal to. I want our actual error to be less than or equal to their provided error. They said no more than 2.5 percentage points, so I'm thinking that's 0.025. I think that 0.05 was just there to confuse you to the fact that you do plus or minus E, but the margin of error just is 0.025. That's the margin of error they want. A husband and wife, Mike and Lori, share a digital music player that has a feature that randomly selects which song to play. A total of 2,384 songs were loaded onto the player, some by Mike and the rest by Lori. Suppose that when the player was in random selection mode, 13 of the first 50 songs selected were songs loaded by Lori. Construct and interpret a 90% confidence interval for the proportion of songs on the player that were loaded by Lori. Okay, so construct and interpret. I'm doing a whole state plan to conclude. So let's go step 1, state. We are trying to estimate the true proportion P, so I'm defining my parameter, of songs loaded by on the player loaded by Lori. Okay, so I've done my state step. Now my plan, I need to first identify my procedure. So we will construct a one portion Z interval. And if I was doing means, I would say a one sample T interval. Okay, so I need to check my conditions. This is random. %% condition, we know there are at least 500 songs, right? Because there's 2,384. And now I need to get normality, so I'm going to do large counts because this is proportions. So I'm going to do 50 times P, which is 13 out of 50, which is 13. That's greater than or equal to 10. I'm also going to do 50 times 37 out of 50, which is equal to 37, which is greater than or equal to 10. So that means the sampling distribution is approximately normal. Okay, conditions are met. I'm going to add myself a slide so I can keep writing. Now I'm doing my do step. Remember, that's entirely done in the calculator. So let me just go in here. All right, and the calculator gives me 0.158 to 0.362. Now I need to make a conclusion. We are 90% confident the true proportion of songs on the player loaded by Lori is between 0.158 and 0.362. That's it. Bye.